Everybody, welcome to this lesson video. This is going to go over lesson 2.4, construct linear inequalities. So the first thing I want to talk about, and what first when we say construct, generally this is talking about from a word problem. So we need to know some kind of key words that go along with our inequalities. Key inequality words. So, let's start with less than. Do that in green. So here is our less than symbol. Some other words you might hear associated with less than is below. 3 is below 4. 3 is less than 4. Under. If I have $5 to spend, my goal is probably to spend under $5, right? I want to spend less than $5 if I want to have some money left over. Lower than also is associated with less than or fewer than. There are more too. These are just some examples. So now, what about less than or equal to? Less than or equal to. That is the less than symbol with the bar underneath. Some words that might be associated with that, at most. If I have at most $5 to spend, I maybe am going to spend up to that $5. Now that $5 is included. Does not exceed. Could reach up to that value, but it does not exceed it. That value that we are less than or equal to is a maximum, or we have no more than that number. So all of these phrases or words go along with less than or equal to. Now, let's talk about our greater thans. So greater than, oops, is the opposite, right? We have the bigger number first and then the smaller number. So our greater than terminology, some words we might hear, if that number exceeds, if we exceed a certain goal, we've met a number greater than what we wanted. It was larger than some number. Let's see. I'm gonna run out of room if I don't. Above. You must be above 60 inches. Or more than. We need more than 100 people to donate to meet a goal. All right. Lastly, we have greater than or equal to. Ah, that is our greater than symbol with the bar underneath. At least actually goes with greater than or equal to. So if I say I need at least $20 to go eat out for dinner, that means I could have $20, that would work. $21, $22, that's a good amount of money for me to take, but anything less than that, it's not going to work. I need at least, or the minimum amount needs to be that $20. It needs to be not under a specific quantity. All right, let's look at some examples constructing linear inequalities. Leo. And yes, I want you to write the problem down. You need to know what the numbers and everything that you are writing in your notes are talking about. So you need to write down the original problem before you do the work. So Dylan and his friends are going to the zoo. They have no more than $90 to spend in total. So as a group, they have no more than $90. Parking, oops, is $14.50. And admission is $9.75 per person. We are going to start part A by writing an inequality. Where'd it go? Where'd it go? Representing P the number of people who can go to the zoo. I'm going to abbreviate here, the number of people who can go to the zoo. All right. So we don't know how many people can go, right? We're going to write this inequality for P. We do know they have $90 to spend, and they can spend, this is a very important word here, no more than, or a very important phrase, no more than $90. We know that a part of their $90 has to go towards parking, right? They're going to drive there. They're going to need to park their car. So when we're writing this inequality, money they're going to be spending, they already have to spend that $14.50 as a part of the $90. And then when they go to the zoo, they are going to be buying tickets for each person. And we know that each ticket costs $9.75 per person, right? Where did it go? $9.75 per person. So this means we can multiply 9.75 times P, the number of people that are going. If 2 people go, we multiply 9.75 times 2. And this needs to be this cost in total, right? Their total cost of going to the zoo needs to be no more than $90. So they can't spend $91, $92, $93. It needs to be less than or equal to 90. So our inequality would be 14.50 or 14 plus 14.5 plus 9.75 with P, and that is less than or equal to 90. Now we are going to solve for P to determine the maximum number of people. So now my goal is to solve for this variable. I want to find out what is P. I'm going to isolate or solve for P. And we have 14.5 plus 9.75 P less than or equal to 90. So if I'm trying to get this P all by itself, first thing I need to do is get rid of this 14.5 extra. I want to figure out how much money they have to spend on just the admission alone. So we're going to take away the price of the parking from both sides. So minus 14.5 from both sides. So those 14.5s will cancel and we'll be left with 9.75 P is less than or equal to 75.5. And if you're not sure about that, put in your calculator, 90 minus 14.5, no shame. Now, To figure out the true number of people that can go, we know that after parking, we have $75.50 to spend on tickets. So I'm going to divide both sides by 9.75. So the 9.75s will cancel and we'll determine that P has to be less than or equal to. And if you put 75.5 divided by 9.75 in the calculator, you get 7.74 dot, 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 dot. And we can't bring 7.74 people to the zoo, but we can't bring 8. It needs to be less than or equal to 7. So this means they can bring at most 7 people. We can't bring 7.74, can't bring 8, right? It can't round up here, so we have to round down. They can bring at most 7 people. All right, let's look at another example. Jasmine is working 2 jobs to save money for a car. If you want to abbreviate, money for car. Oops, this is an R, not a V. She makes $15 per hour tutoring and $13 per hour, abbreviate there, as a barista. She must earn no less than $160 this week. So first, we are going to write an inequality. To represent this situation. I'm going to say actually to model. All right, so we actually don't have any variables defined, so I'm going to set up our variables. And she has 2 different jobs, right? And she's going to be working different amounts of hours at these jobs to make different amounts of money. So we know that she makes $15 per hour tutoring. So I'm going to make T one of our variables. And T is the number of hours that she tutors, because we don't know that. So number of hours tutoring. And then the other job is as a barista, where she is making $13 per hour. So I will have B represent her number of hours as a barista, which a barista makes coffee, like at Starbucks or wherever you go to get your coffee, if you drink coffee. So let's talk about how we would write this inequality. We know that she's going to be working these 2 jobs together. So the money she brings in will be added together. And she's going to make $15 per hour as a tutor. So I will multiply 15 times T to find the amount of money she's going to make by tutoring. So we have 15T plus the number of hours she's working as a barista, where she will earn, I'm trying to get to the yellow there, $13 an hour. So 15T plus 13B, and then she must earn no less than, not less than, right? So that means then she should earn greater than or equal to, no less than, so that counts, $160. So 15T plus 13B has to be greater than or equal to $160 for total pay. If she works 4 hours tutoring And where did it go? 10 as a barista. Will she meet her goal? So let's see. She's working 4 hours tutoring. So here this means T is 4. So if T is 4 and her hours as a barista is 10, so B is 10, will this work? So in my inequality, we had 15T plus 13B needs to be greater than or equal to 160. So now I'm going to substitute in. She's going to make $15 for her, or per those hours as a tutor. She worked 4 hours as a tutor, plus $13 times the number of hours she worked as a barista, which she worked 10 hours. And that needs to be greater than or equal to 160. And then if you want to just put this in your calculator, you certainly can do that. 15 times 4 is 60. 13 times 10 is 130. You add that all together and you get 190 greater than or equal to 160. And this is true. She would meet her goal. All right, last job, or last problem. Asriel has D dimes. This means he has, we don't know how many, he has a D number of them, and Q quarters. Oh, oh my goodness. He has fewer than 23 coins altogether. Write an inequality to model this. I gotta stop tilting my head to model this. So they defined the variables for us already, which is so nice. They say D is our number of dimes and Q is our quarters. So let's write that out. D represents the number of dimes he has. And Q is going to represent that number of quarters he has. Number of quarters. So to write this inequality, we know that all together, or if you add together the amount of dimes he has and the amount of quarters he has fewer than 23 coins. So the number of dimes D plus the number of quarters Q has to be fewer than or less than 23. And that's it. You just add D, the number of dimes, plus Q, the number of quarters, needs to be less than 23. Let's now, last step. He has at least $2.90. Write an inequality to model this. So we have to now think about the value of dimes and the value of quarters. We know that dimes are 10 cents, but this is talking in terms of dollars, so that is $0.10. And quarters are 25 cents, so that is $0.25. So we know if he's adding together the amount of dimes he has plus the amount of quarters he has, we can find the value by multiplying the amount of dimes he has by 10 cents each, or 0.10 times D, plus 0.25 times Q. So the value of his dimes plus the value of his quarters is at least $2.90. And at least means that $2.90 is actually the minimum. So it is greater than or equal to $2.90. And I don't need the dollar signs. If you actually graphed this inequality and the top inequality here, you would have a system that worked together and you could find the true number of dimes and the true number of quarters that make both of these true at the same time. Please let me know what questions you have, and I look forward to seeing you in class.